So what this talk actually came from was I was at a conference about a month ago, maybe 2 months ago now, and the idea of the talk was a number of advanced concepts in continuous deployment. This is something we're doing at Etsy. How many people are familiar with continuous deployment at Etsy? Heard that story? Okay, so we're basically deploying our site, which is much more of a monolithic app, not a microservices app. But we're deploying that about 40 to 50 times per day, and we've distributed that across our engineering team. So one of the advanced topics that I was talking about was how do we do that? How do you get that many people deploying in a single day, and what does release management look like? So tonight is basically one piece of that talk, one quarter of that talk. I'm going to try to do it in 20 minutes, see how this works. So when you do a lot of deployment, you've got this process that you've got to do very, very rapidly. And when you hire people and onboard them, the first thing you need to do is figure out how to onboard them into that process. You're interviewing software engineers, so you're testing essentially and learning how much they know about engineering, and you're going to trust that they understand that. What we need to teach very, very early in our life cycle for engineers is how to go through this deployment process. Because the worst thing you can do is build up a bunch of code over a number of weeks and then be shy about deploying it. So the first thing you do on the team is you deploy code. Which means we give you a very simple exercise. We have one of these pages on our site because we're a tech company and it's 2014, where everybody's face is on the about page. So the exercise is check out the code base, get your VM running, understand where the templates are, how to get this, get your own image in there, commit that, go through all the tests, and learn how to go through the deployment process. And so I want to talk about what the deployment process actually looks like, because it's not something you would have gone out and planned on your own. This is something that we've done over 4 years, and some of the stuff is surprisingly close, but a number of things are finesse and subtleties that we've added over time. So I just want to mention, why would you want to do deployments so frequently? We do continuous deployment, particularly so that we can get code from a developer's hands or mind into production very, very rapidly. I find a big switch between developing code in a dev environment where you've got test data, or even being in a stage environment where you're trying to simulate data, versus what actually happens in production where you have live users and live data and data that's existed for a product that's been around through 9 years of iteration, which, despite all of our best attempts, we've never been able to simulate that properly in dev. We always find some kind of surprise when we go from dev to stage to production. So it looks a bit different. App deploys throughout the day. We have 2 different kinds of deploys. A full app deploy, which is all of our code, and then config deploys, which are a couple of config files that live with the code base. But we can deploy them more rapidly because they're much more lightweight and we run fewer tests against them. So app deploys are like big bits of new code, new unlaunched features that are gated by config flags. It might be simple things like graphics or style sheets or type changes and things like that. In some respects, your entire site becomes a CMS if it becomes easy to deploy it. You don't have to go through an IT department. And then config deploys are these flags that allow us to turn on and off different parts of the application. So one good example of this would be if we wanted to turn off search for the entire site, we have a flag that turns off all the search. So we take all of the traffic off the search tier, we would kill the search box in the UI, and that would allow us to resolve an issue with search if we actually have a problem with it at that layer. And we've got thousands of these flags. That allows us to essentially operate the site. So our engineering team, when you talk about DevOps, for us that really means bringing the engineers and the operations team very, very close together. So it's not the ops team running the site and the engineers writing it, but we're all working together on this. So we talk about this idea of operating the website. We write code, we deploy it, and then we maintain it in production, and we learn through how the application works under live traffic, how to write better code over time, and how to respond to issues, and how to make more resilient applications. So we started coordinating our deploys in RFC. At some point we This is really starting in 2010. We had about 22 engineers on the team, and we started using a one-button deploy tool. It's very, very easy with our application to deploy it, essentially with rsync and a few other scripts. But we said, we got to figure out how we know who's actually deploying at any time during the day. So we'll just do it in IRC. We'll make a new channel called push. And then you've got the next question, which is who's deploying and when? Whose turn is it? It's another simple solution. And again, this is like just people coming up with like super stupid, easy solutions. You just put everybody's name and delineate it with pipes. And over time we found that was too slow. So we stacked some people up and we made commas instead of pipes. So we'll have 3 of us deploy at the same time as a group. And then we'll have another one after that. And that worked pretty well. And you'll see as I get into this a little bit further, at some point, when I put my name in and John and Ross put their names in, sometimes you have collisions when you have enough engineers. So multiple people munging the topic at the same time. And I get kicked out of the queue. So we've come up with some solutions for that. And I'm going to point out that this is, we were sort of piggybacking on some of the continuous deployment stuff that had been going on at Flickr and IMDU back in 2009. And at IMDU, Timothy Fitz, if anybody's familiar with the work that he's done and what he's written up about continuous deployment, they had a system where if you commit code and it passes tests, it automatically starts deploying to production. It goes through a system of canary pools and health checks to make sure that that's stable and then continues to deploy afterwards. We wanted to keep real people in the loop. We wanted to avoid the situation where I hit I commit something and then I get up and go order my lunch and walk out and just assume that the tests are gonna fail and save me or something else in there is going to save me. So we wanted people to be involved at all points of this. And then along with that, I said that we sort of stack people up. We found over time that the optimal queue size or batch size for us is 7. And we did that by just literally analyzing our IRC logs for how quickly people move through the queue and figuring out that in larger batches, at some point, there's so many people that you add too much complexity to every deploy. And if that deploy goes wrong, then you have a longer period at which you're trying to diagnose what went wrong and solve that. So we just came up, we found that the optimal number for us at the time, we're still using this, is 7. That keeps the queue moving quickly, but generally limits complexity to a reasonable size. So like I said, this is all in IRC, and I'm going to apologize because when I did these slides before, they were on a gigantic screen, and now I'm going to administer the eye test. So I'm just going to literally walk you through what happens in IRC, because I think this is the part that we take for granted all the time. We basically say, like, we do this in IRC, and we've got one button deploys, and that's it. But how all this is coordinated is really kind of interesting. So in the beginning, how many people cannot read this? All the hands are going to go up. Okay, so I'm going to read through as much of this as possible, and I can barely read it on my own screen, so I'll read it over here. So we start out, and what happens is we've got a bot in channel, actually, called PushBot, and it is maintaining sort of fluidity. He's normalizing communication, and you talk to the bot when you want to join the queue, and the bot tells you when you're up and what's going on with the push, and it keeps things orderly. When you don't have this, you have humans saying, "Is your stuff all right?" And somebody else says, "Cool, man," and you're like, "What do you mean by cool?" So PushBot sort of normalizes that kind of communication, which is interesting. What's that?
Like a traffic cop?
Yes, a bit like a traffic cop. I also think about truckers in some respects, or air traffic controllers who have like very, very short communication. So each of these people are queued up, and PushBot says it's actually your time to deploy. So you're going to get in and you're going to commit your code to master, and then you're going to go through the whole deploy sequence. So each of these people uses a command, .in, saying, I've committed and my code is in. I am ready to go. So when everybody else is ready to go, feel free to push us along to the next step. And after everybody in that deploy is checked in, then PushBot says, okay, everybody's ready to go. Adrian, who's in the front of this queue, is designated the driver. This is like being in the jury panel and being selected in the first position. Anybody else had that happen to them? I had that. I had to read off all of our verdicts at the end. It was kind of a pain. Really awkward. So Adrian is driving, and he's going to use our deploy tool, which is called Deploynator. This is on our. That's fun. This is on our GitHub page. If you want to use, if you want to find Deploynator and try that out, it's literally like a nifty sort of UI front end on top of a bunch of shell scripts and other garbage that you use to deploy. Everybody has this to deploy their code. We just have a nice UI on front of it. But this is sort of water cooler, we say, for like the status of deploying, because you can see everything that's going on here. These are all our Git SHAs for each environment that we're in. We have this is our test environment where the tests are running. This environment is called Princess, because everybody has an environment called Princess. It's actually pre-production and then production. So you can see the state of what code is in each environment. You can see the push topic from IRC. You can see the log of all the things that have ever been deployed. And in these include run logs of the actual deploy, the diffs of the code, and dashboards. We'll get to dashboards for monitoring. This is the deploy progress, or the build progress. So the QA tests are running right now. These buttons would highlight and be active if you could actually deploy in those environments at the time. So they actually lock out when you're in some part of testing. That is so distracting. So next, we've got another bot called DevBot. And DevBot says, okay, we've got the test started. And then Jenkins, our build server, comes in and says, all right, we're starting the build for QA and for Princess. So we actually, interesting thing here is instead of deploying sequentially on these two environments, we deployed both at the same time. Because culturally what we found is that the people test in QA first, they make sure everything is passed, and then they make sure that the tests and everything are passed in Princess before they actually go to production. But we just found that we could save a few minutes by deploying both of these at the same time. And it actually hasn't caused any problems for us. So then we're 5 minutes further down along here, and DevBot pipes back in and says, okay, now Princess has been deployed, and PushBot says your code is on Princess. So these two bots are talking to us, giving us constant status of what's going on throughout the thing. And one of the things to highlight here is that because you're in IRC, who uses IRC at work? Okay, who uses some kind of chat at work? Yes, we all work on the internet. So because PushBot keeps using the nicknames and channel, everybody who's in the deploy keeps getting a notification on their desktop saying, hey, here we are, here's where we are. Constantly bringing you back into what's happening so you don't get distracted. This whole process will take a series of minutes. Right. So the bots keep you apprised of status. I've said this basically, but the interesting thing here is we've also got links going to the run log of the deploy. So if something actually goes wrong, we can go back to what the build scripts output were, and you can see the diff. So when we've had these 4 people commit all their stuff, now I can see a link to the diff that includes all of their commits in one versus what the last deploy was. So I can see an entire change set that's going out to production. And we've got a bunch of bots talking to each other. At this point, Mike, who's right here, jumps in and says, hey Kevin, is that hold yours? So at some point, Kevin in another channel has issued a hold on a deploy, and Kevin says, yes. And he says, okay, well I'm joining. So this .join means I want to get into another deploy queue in the future. And PushBot is going to put him into the pipe delineated things with the maximum batch size of 7. PushBot's going to maintain that for us. So PushBot is the one who always maintains the topic in this channel and maintains the queue going through. And then Kevin's talking here and Mike's talking back. And so not only do bots talk to us, but humans talk to each other. Although this is generally in the push channel, general communication and banter, although like we've got channels for that, we generally discourage it. So this channel is generally moderated for, keep the cross traffic to a minimum. Talk about what's going on with push, because this channel is like, I don't know, it's like air traffic control, like I said earlier. Like you want the channel clear and understand so that you can see when something comes up and somebody says, hey, something's wrong with production, we should jump into that. That we're not losing track of it by like pictures of cats and stuff, which happen a lot because we're on the internet. At this point, DevBot says Princess is deployed, and PushBot says your code is on Princess, so notifications are going off. Gerard says bueno, because our bots speak Spanish too. But basically what he's saying is the code that is deployed, I've checked it in a browser and my changes look good. I've done my ad hoc testing. My stuff is good. Instead of, cool bro. Where else? Okay, so what happened was I mentioned that Princess and QA got deployed at the same time. Princess landed first. QA is, the QA build took a little bit longer. We have success, and we've got a timestamp, like a duration on here. We shoot for an SLA of tests, all of our tests for QA, all of our tests for Princess, all of our smoke tests in production. All of them are expected to be under 5 minutes, and this is actually a failure here because it's a little bit over 5 minutes. But if you're going to deploy this frequently throughout the day, that means you have to keep your tests really trim, not flaky, and though we have thousands of them, they're parallelized so we can do this really rapidly. And we've got a team of people who literally run our CI infrastructure and make sure the tests are passing. We've got a huge dashboard of test durations over time, and you can see that creep up over time and say fix and creep back down. But that's an entire role to keep this process moving quickly. Let's see here. There is, like I said on here, there's a link to the test results in CI. So this link goes to our Hudson server, and you can see all the tests that have been run in there and the status of those. If that fails, that's where you're going to go to figure out what actually failed. So at this point, we're 8 minutes in. We've got everything passing on QA, and yeah, the QA failed the SLA, but we're passing QA, and everybody's going to start checking in to say that everything's cool to go further. Here, DevBot is saying everyone who pushes run try recently. So try is actually a pre-commit cluster that we use for testing. So what happens is, because everybody's committing to master all the time, and you want master to always be green, you have to have some way of validating before you've done that all of the tests have passed before you commit. So our try suite is basically a way that you can say, take this patch that I'm about to commit, run it on a cluster that's going to parallelize all those tests, and tell me if it's going to pass before I've committed it. And then what you're seeing here afterwards is the stuff that is actually committed as a group together. So we've got 4 people integrating their code together, and then the tests are running again. So DevBot is saying, in this case, all 4 people who are in the deploy, actually there's more people in the deploy that you're not seeing, but everybody who's in the deploy has run try recently, which was previously a problem because people would sneak stuff in. Like, it's going to take a few minutes, I'm just going to jump in here. So this gives us a little bit more validation that the people who you're in the train with are also looking out for you. They're doing their part. Let's say, if Adrian had not run try and didn't know that his tests were passing before committing, it would call him out here. And surprisingly, that's a really effective way of getting, have bots make fun of people instead of humans. It's really effective for instilling certain parts of your culture. So, Jenkins says that Princess still is a success, so now we're on our pre-prod environment. The tests only ran in just a little under two minutes because they're a different set of tests. They've got some functional tests in there, but fewer of the, well, actually none of the unit tests. And then PushBot is again, with the usernames giving status. So we're still only at 8 minutes, and we're on to our pre-production environment. With only one more deploy to go to get to prod. So now, again, here's Chris saying I'm going to join the next queue, or whichever one you want to put me into. And these guys are now saying, my stuff is checked out and it's good to go. And PushBot jumps in here and announces that in another channel, in in our config channel, a deploy is going to Princess, deployed by Chris, and here's a similar thing. So there's actually, because we've got this app deploy and config deploy, we're doing those in separate channels, and we can do those in parallel as well. But we have this cross-traffic announcing that something has changed on our configs, so that if something goes wrong with the people who are doing this deploy, they have a heads up now that there was another recent change into production that happened. And now Adrian has said that he's good, and Pushbot checks back in and says, okay, everybody is ready now. We're going to check Jenkins. So he asks Jenkins for status. Jenkins says, here's your last build. Okay, I'm going to ask you again for status on Princess. Here's the last build for Princess. Bots, talking to bots. And then we have this is the button that is in Deployinator. And right above the button, really clearly is the hash, the SHAs that are changing when you go into production. High visibility throughout the entire system. So now Adrian has pushed the button. DevBot in channel is saying Adrian pushed the button, confirming that this happened. Again, cross traffic. Now it's Chef. Anybody use Chef for configuration management or Puppet or any of those? Right. So what we found a little while ago was those systems will run too and inject surprises in production, and people who are deploying code will get surprised because they think that they just screwed something up. So we stuck that into the deploy channel too. So anything that's changing in production, we try to make sure is surfaced here. Now, our bots are popping back up again. Starting a build job for prod. Production deployment happens. Your code is live, so now the code is available on Etsy.com. Here's a link to our dashboards where you want to look at metrics that we're trending over time and see if anything has tipped up or down. Here's a message down here. DevBot is saying, here's the committers in the above push. And there's actually, I think, 7 or 8 in here, whereas there were only 4 people in the deploy. And what happened was that we have a couple of people who had essentially new code, like a brand new, say, like class file or CSS file that's not linked to anything on the site, but they're just committing into the code base. They've got some tests. Code that is not live to production, end users won't see it. And so we allow them to just sneak stuff in dark without having to be active in the deploy. And this is, like many things, it's a judgment concern. We get burned by it occasionally, but you learn a lot from it. Now the build for production is only 42 seconds. It's passed. It's basically some smoke tests and things like that to make sure that all the configs are in the right place and that everything is working. And then Pushbot, again, notifying everything is passed. So then it's a chance for, I've mentioned this already, right, so the link to the graphs. We have a dashboard, we have hundreds of dashboards. But this is part of a deployment dashboard that we use. So there's like one thing that everybody can look at, the same business metrics, the same app metrics, the same network and system metrics. It's about 73 graphs on the same page. You basically scroll through it and look for something that's amiss. And what you'll see is a bunch of these vertical lines on here. And this is over a 2-hour, 4-hour period. I remember there's about 25 deploys in this period. So all these vertical lines indicate that something was deployed to production. And what you're looking for is something like here, where here's this trend line for redirects that are happening on the site, and some config deploy. Blues are configs, reds are app code. So a config deploy happens, and we've dropped the redirects. And that was because, in this particular case, we're changing the way that we're doing SSL redirects. We're in the process of rolling out SSL to the entire site. And so that was a particular deploy that had to do with changing some of the configs that manage that. But generally, these are things like registration on the site, logins, checkouts, things that we want to be healthy and normal. We don't want to see these drop off erratically when we deploy. So now we're 13 minutes in, and we've got code running in production with production traffic. We can see all the people who have deployed. Everybody starts checking in and saying, my stuff is good, my stuff is good, my stuff is good, my stuff is good. At this point, Pushbot asks for status again on prod. Jenkins responds and says everything is done. Adrian, who is driving, now confirms we're done with the push. and pushbot says, Kevin, who's next in the queue, you're up. So now Kevin is getting a notification at the top of his screen that says, it's your turn to deploy. And then everything moves on. So this particular app deploy, 15 minutes. We had 4 people actually running the deployment, so actively engaged in deploying the code and monitoring what's happening. 8 people who were committing code, and then you saw like cross-traffic in there as well from a couple of other systems. And like I said, this is a 4-year effort. Subtly, we make changes over time on this. We figured out the optimal queue size. We've really worked towards normalizing communication, keep things really, really tight. We've got really good visibility of all the things that are changing, and that has added over time. We didn't have all those links to dashboards, and we didn't have as rigorous a dashboard early on. And then the awesome thing about this is that when something does go wrong and we have postmortem, we've got this great journal of people actually talking about what they were doing. And they can go back to it and they can remember, okay, yeah, that's what I was doing, and this is what I said. And if something was going wrong, you might see Kevin say, oh, I've noticed that something's wrong with the checkouts graph, which happened on Friday. And then you can turn back to what actually happened, along with all the diffs and all the dashboards and things like that. If something does go wrong, we have a command that's old, and it just causes the push queue to stop. It lets everybody know in channel we're not deploying until we get it solved. We work the issue with the people who are in push, and then there's another channel for sysops where all our operations team is hanging out. We'll get them involved, and so there's always people available to help diagnose and fix issues that happen in production, especially if they're deploy related. And if we ever have to do like an off-hours push to resolve something, which is usually limited, we'll buddy up. So we'll make sure that, like, I'm going to call Mike or somebody else and get him to ride along with me and sanity check everything I'm about to do. The punchline is that this works on a great big site. We did 1.3 billion in sales last year. And people used to say, like, yeah, the continuous deployment thing would work for about 3 people. We think it does a little bit better than that. But this has grown up over time. And so this is our deployment rate over 4 years. This is back in 2010, and you can see not that many deploys happening every single day. So this took us some time to get to. The red is our config deploys. These are the yellows are app deploys. So in essence, what happened if you stack these is this is actually way up here in terms of total frequency. The arrows, who works in e-commerce? Anybody else? All the yellow hands probably going up. These are, that's like Cyber Monday and like 2 weeks following. The great thing about this system that we've learned is because we do it all the time, we have really high confidence and we're making very small changes all the time, we have good validation tools and good exercising of deploying. So we feel confident that if something goes wrong or if we have to make changes during the high shopping season, we have the confidence to continue pushing. Otherwise, we'd have a full code freeze and this would be a flat line here for about 3 or 4 weeks. And that saved us a good number of times. The first holiday season I was here, we had to do like a major search algorithm change on day 1, which was scary. So this is part of a bigger talk, but there are a few takeaways you probably gathered from it. We took this really slow as we built it up. We iterated on it over time. There was always a way to go back from what we were doing. Like if we didn't like doing this, if it felt too fast, we could always revert and go back to something else. You're probably not going to do what we did. If you wanted to do something like this, go roll it yourself. We saw a bunch of ideas from different places, but what you saw was how we've implemented ourselves. And that's what I have. Thank you. Okay. Any questions? Yes?
So what happens if, say, the QA tests fail? Do people get a chance to fix it, or they get picked, or is the code rolled back?
Yeah. So what happens if the QA tests fail or any of the tests fail? It's judgment call in Q. So there's nothing that is by process or by automation. Like they don't automatically get kicked out and move on. The group will look at what happened. I'd say generally, like, it's pretty clear whose code, like, what happened. Oftentimes somebody will step up and say, well, I had something in there that I wasn't 100% sure of. Or sometimes, like, you and I might commit at the same time, and we've got something that actually does conflict with each other. So you go into Jenkins, find out what's failing. If you can identify it quickly and understand what it is, they can put a patch out quickly. And again, these are pretty small because we're deploying a lot. We have very small change sets, so it's easier to look at the change set and generally identify what's going on versus like weeks and weeks of code deploying at some point. If you can't, somebody will revert their code and then the deploy will go on. So just sort of like figure it out. And everybody, like, there's a well understood aspect of it, which is we need to keep this moving pretty rapidly because there's people behind you waiting to go. And so people have learned to jump out of the way and just say, like, you know, save yourselves. Yes?
So is it mandatory for all the people who have committed the code to say good or bueno to move in the next step? Is it mandatory?
Yeah, so is it mandatory for everybody who's committed to identify like good or done or any of those status checks? Actually, what I said was kind of a lie. Anybody who is in the push channel who is deploying something that they feel is related to active code in some way. So I mentioned that there were 4 people you saw who were regularly checking in, but there were 8 people total who committed. So the other 4 were committing code that they knew was cordoned off from production. They weren't concerned about that. So they are not registered in with Pushbot, and they don't have to tell Pushbot that their code is good or whatever. So it's only the people who are in the queue proper.
Right. So basically, who initially registers saying got joined.
Right. So if you were to say, like, I'm going to join this deploy, when you get in there, as you go through the entire process, it keeps asking you to check back in. Okay. So it prevents you from joining, and then, like, you know, 2 hours later, if things were going really slow, what can happen is if you have a hold or something goes wrong in production, you can get a big stack of people, and, you know, somebody ditches off for a bit or, like, gets called into a meeting or something like that. The group will identify pretty quickly if that person is still present, and if not, they'll kick them. They'll kick them out of the queue, and then they'll progress otherwise. Yeah.
So you do code review?
Yes. We do code review. Every team does code review within their teams. Okay.
Continuous deployment is very dependent upon the quality of the testing. Of course. How do you maintain the quality of your tests? How do you measure that? In other words, do you have metrics for code coverage and the like?
No.
And what prevents somebody from just cutting corners and saying, yeah, well, this is enough tests?
You can do that.
To do it.
So the question is, if we're relying on quality and continuous deployment, how do we measure that and validate that? So going back to code review, like, teams will institute a certain degree of confidence within their change sets. Not every change set is going to have code review or tests that go along with it. Each team, and to some degree down to individuals, will decide how much coverage they want to have. We don't institute a specific percentage coverage or anything like that. What we shoot for is that everybody on the team, like, very much the same way that we give you authority to be able to deploy this, we also push the judgment of how much testing is right to build confidence for you in your change set, as well as that when somebody else comes along, which will happen in the future, that they're not going to get surprised and like make some like subtle change and like tip off something that's like going to break all your business logic. So it is a judgment call for us.
Okay, but in particular corner cases and edge cases that may not happen except for, you know, once in a blue moon, you may not, you know, see the results of that, of it failing badly in the field, you know, until maybe days, even weeks later. And that'll be hundreds upon hundreds of deploys later. Now it's hard to associate that failure with what caused the failure. So
would it be any easier any other way if we did months of code?
Well, you end up putting more time into the testing, into the coverage, and what have you, and then it's, you know, it's more of a big bang integration than the continuous integration.
Yeah, we happen to prefer the continuous integration aspect, and the piece that is not as heavily focused on in this talk is those dashboards at the end that measure user behavior. And what will frequently happen is we'll run into something that we didn't think to test, or maybe just blatantly didn't test. But oftentimes it is, you know, this particular case is a total pain in the ass. We don't think anybody's ever going to trip into it.
Right.
We're not going to test that. We don't think it's that big a risk. We deploy it, and then, like, you know, we drop off registrations by a certain amount. Okay, we should probably go fix that. We do rely heavily on our ability to detect those problems quickly and to revert them or solve them quickly, as opposed to having, frankly, before we started doing this, we had deployment processes that were like 6 to 12 hours long, and it was weeks of code in one batch. So we were moving to get really, really far away from that.
Yeah.
To enable our team to move very, very, very rapidly. Even if, you know, we know that we're going to trip up things that are wrong, but we want to be able to detect those really quickly and solve them really quickly. Yes?
So do you guys do rolling deployments? Exactly how do you handle getting your new deployment into load balancer and starting to direct
Right.
traffic towards it? And is there any performance degradation associated with deployments?
Okay. How do we do deployments from, I guess, an operational standpoint? So most of our app code for Etsy is PHP, so largely rsync scripts. There is a post on our engineering blog, which is called Code is Craft, which details a few of the real intricacies we've had with that, which is that we use the op cache in PHP, and what will happen with that by default is the files in the server, the inodes will get cached for them. And so we've had to like write an extension that will look at the real path of the files. And we deploy to two separate directories. So we go to one, and that's live, and then we deploy into a dark directory and then do a symlink switch. And so you have to make sure that the symlink is not cached, but that you're actually looking at the real path on disk. That's for our main app code. So basically we can just rsync right into, we used to rsync in the live directories, and because it was so quick, you don't really have anything that picks up in terms of errors. In our search tier, we used to do rolling deploys, but we found a good bit of stress, and one of the engineers I was talking to recently said this was like essentially fraught with peril. Felt like he was constantly like dealing with, you know, a half deployed thing and then having to roll it back out. So what we've done is we've stood up 2 clusters of the search tier. We always have one dark. Actually, there's 3 because we also have an experimental cluster that we'll deploy to, and we'll like load balance some traffic onto it to do testing that way. And that's on the JVM. So we have like one that's live, and then we balance traffic over to the other one when we're doing deploys. We'll deploy the code, get it all ready, run tests and everything like that. Pre-warm the caches, pre-warm search, and then start moving traffic over to it. And the way that we do the traffic moving is through the config files in the application code and not through a load balancer.
Okay. And do you also prime the interpreted side of the PHP? I know there's a little bit of latency, right, the first time you hit pretty much any interpreted language.
Yeah, we haven't had that.
It's just not noticeable.
No, not noticeable. I think that one of the things we get away with is that there aren't that many files changing, so a good number of them are staying cache. The other thing is we use this Smarty templating language, if anybody's familiar with that, and we do translations into a number of different languages. So you end up with, if we did not, we pre-compute all the templates, and so they are ready to go, and they're in pure PHP by the time we're deploying them, instead of like Smarty that's compiled at runtime and then cached at runtime as well. And that's a pretty expensive process for us. Sorry.
Right, do you find new developers being intimidated by this process and continuous deployment in general?
Are new developers intimidated by it? So you're teeing me up for a great question. Great answer. I don't think so. One of the reasons why we do this is because we think it empowers individual teams to move very, very rapidly. And one of the stories I really like telling about this is that the first engineer on my team who went through deploying on the very first day, within his first week he had deployed 7 times and fixed 4 bugs on the site. And I thought he was a maniac. And I said, you know, what is going on? Like, I thought you might do this once or twice this week, and you've done it 7 times. And he said, well, I just came from a company where I wrote code for 9 months that never saw the light of day. So we balance those things. People who want to write code that actually sees, like, has an impact. This is what we think is the fastest way of getting there. Yes?
It's funny you mention it because I look at this and I think it's a slow process. Why have humans involved? I come with an environment where I push just constantly, and then automated tests run. If I push tests, I get kicked out, but otherwise it just keeps going all the time. I don't even know how many times a day it goes, but it's going. So why have humans?
So we thought about that, and I said at the beginning, like, we like the idea of having humans involved because we get surprised by the things that go wrong. And by having humans involved, it means that we always have a group of engineers who are thinking about deploying to production and thinking about what's going on in production. The side effect of having them involved with it is that they're essentially a small ops team on call for the period of time that they're in the deployment. So they're always available to respond to their own problems. Yes, you can kick people out and automate that kind of thing. We just decided not to do it. We like having people involved. Jesus. There we go. Over here.
2 nitty gritty first. What do you have an
Okay.
What?
I'm told it's the last.
Sorry, last question.
Okay. Sorry. So quick nitty gritty and then a kind of a big picture question. Do you have an SLA on how long the deploy is allowed to last? You said
it's allowed to last?
You said 5 minutes for the test. What about the deploy as a whole?
So we don't have an SLA for the entire process as a whole. We break it down to the pieces that we can control through, like, software.
Mm-hmm.
I can't really control somebody from getting up from their seat and walking away and going off their reservation when they're halfway into a deploy.
Mm-hmm.
That's where being involved with your peers, you get pressure from people. Like, there's an expectation that you're involved, and there's, you've had to wait behind other people to deploy. People are waiting behind you. Like, you learn pretty quickly that you want to move quickly.
Mm-hmm.
So yeah, we don't really enforce a specific SLA on that whole thing. But what we can do is keep forcing we keep looking at the pieces. This, like I said, we've iterated on this over time, and we keep iterating on things that will make it faster for us to get code from first commit to deploy, and also to identify issues that happen in deployments as well. So like all of those status checks, all the links to tests, test results, all the links to the diffs that happen, all the links to the run logs, things like that, have helped us identify issues quickly. Because if you looked at the histogram of how long each deploy took, you have a lot that are only about 11 to 16 or so minutes, and then you have a bunch that like go out much further. And there's some cases where you have a deploy and you might spend 3 hours where something goes heinously wrong, and it may not even be related to the stuff you were deploying at the time, or it may be a completely fundamental surprise in what you're deploying. But things can go wrong, and like you can't really. What are you going to do with the SLA? Like, fire everybody? No. That was this big picture question.
No, the big picture question is, what does our industry look like when this is a product that any team can drop in?
And with that,
Any big picture answer?
what does it look like when anybody can drop this in?
Yeah. What does our industry have to look like before that can happen?
Oh, what does it have to look like before that can happen? Well, that's a better question. So I think that an important aspect of this is comes back to DevOps and also a blameless culture. We push, because of the way this all works, we push judgment out to all the individuals on the team, which means that for me, if we have a problem with this system where there's a rogue element or like this turns into a disaster really caused by humans, I think of that as a recruiting error, like that we've failed to hire the right people, or that we failed to train them in the right ways, and instill a culture where we're all looking out for each other and we're all trying to do the best effort, and we're going to use our best judgment along the way. And there's something to be said about like where the industry needs to be, I think you need to have the entire industry feel that way too, which I don't think is true. Cool. Thank you very much. I'll be around.